When I was in the 4th grade, I became intensely interested in geography. And I learned it well. In fact, by the time I was in the 6th grade, I could bound every country in the world from memory. Well, then the thought occurred to me, what would the geography be like on the other planets? So that was my natural interest into astronomy, you see. So I've been interested in that area particularly ever since. Well, of course, I took all the science and math that I offered in high school, and I had an uncle in Illinois who we lived in Illinois, and he's about 9 miles from us, and he was an amateur astronomer, and he had a 3-inch telescope, and so the views with that telescope were my first views of the rings of Saturn and Jupiter's moons and the craters on the moon. So I was interested in eclipses when they occurred, things like that, and then later, my uncle and my father invested in a Sears Roebuck better grade telescope, which I used thousands of times to look at objects in the sky I read about. So that was always a thrill to find them in the sky, you see. I was interested in telescopes and the way they worked and so on, because I had an intense desire to see what the things looked like, you see. And so I learned how to use telescopes and find things in the sky. Although my early equipment was very modest, the later I made my own were more powerful. It wasn't a very good one because we had such meager instructions. But it worked fairly well, but not good enough to suit me. And so the following year, the Scientific American published a book called Amateur Telescope Making. Well, I bought a copy and I digested it, and I realized where I'd made mistakes, and so the next telescopes were much better because they had the benefit of the more information. So the 9-inch, which is in my backyard, you probably saw it there, was the 3rd telescope of excellent quality. It was the drawings I made of markings on Mars and Jupiter with that telescope I sent to the Lowell Observatory in 1928. That impressed them favorably, so that they invited me to come out for a trial work with a new telescope, Flagstaff. So that was a big break. So what you do is you have your sheet of cardboard or a drawing board with you in hand at the telescope and a pencil, and you look in and you make some markings on the paper, and then you look in again, back and forth many, many times, so as to get the stuff in the right proportion, the right intensity. It takes about a half hour to make a good drawing that way, you see. So, and when the temperature is freezing, it does get a little hard on your fingers. But I was interested in putting down what I saw, and so that's what paid off. Well, of course, at that time, the Lowell Observatory was the only planetary observatory in the country, and I was particularly interested in planets at that time. And so I thought, well, I'd just like to see what they think of them. Well, of course, the planets are never the same twice. They're always different. And so they could see from my drawings, they could compare the markings I had drawn with their current photographs, and they knew that I was drawing what I was really seeing, and it wasn't copied from somewhere. And so they realized that I was careful, the quality of the drawings, I was careful, I saw well, and so on, and so they thought I would be a good candidate to run this new photographic telescope they were installing. I was assigned to taking photographs at night with the telescope as a wide-angle photographic telescope, and 1-hour exposure, and then I developed the plates and so on, and a few days later I would put them on a special machine called the blink comparator, where you compare 2 plates rapidly, alternating views, to see if any change occurred on the star field from one plate to the other made a few nights later. That was the technique, you see, because these plates would have several 100,000 star images apiece. And if you don't think that's an awesome thing to look at and realize you had to see all those images, which one moved, you see. So the challenge there was far more difficult than most people ever realized. But I had some soul-searching questions of myself. Do I want to go through this very tedious job or not? Well, I didn't want to go back to the farm to pitch hay, and I knew that they'd hired me to do this job, so either I do this job because I didn't want to go back to the farm. And so I went through some pretty tedious and hardship cases to accomplish this. But I was dedicated, and I liked the work, really. And I was very, very careful. All the suspects are checked with a third plate, did the job very thoroughly, and it paid off. That's where others failed because they were not careful enough. Their strategy was not good. And I'd thought this thing out very carefully in my own mind of how to do this, you see. And it worked. Well, Percival Lowell interpreted some of the what they call residuals, slight irregularities in the orbit of Uranus, particularly in later Neptune, as indicative of a mass out there as yet unseen, like the case of Neptune being discovered mathematically before it was seen, you see. But these residuals were very, very small. In fact, so small that they were questionable whether they were real or not. But it was the best that he had. And so he predicted there was a planet out there about 7 times more massive than the Earth, beyond the orbit of Neptune. And of course, Pluto does not have that much mass. As daytime, I did the scanning. See, when I took the photographs, I had no idea that Pluto's image were on those plates. Not until I began to scan them carefully, sometime later. In fact, it was several weeks later when I got to that pair, and I encountered, as I going through all these alternating views of star fields, and here's one that shifted position by the right amount. Now, I had figured out beforehand that if there was a planet X, how would I recognize it if I encountered it, you see? So I thought all this out beforehand. And so when it came, there it was. Instantly, I realized I had found a planet beyond the orbit of Neptune by the amount of shift. I knew the scale of the plates, I knew the interval. It's just a matter of geometry. I had taken the plates of the telescope the previous month, in January of 1930, and I did not know that I had recorded the image of Pluto on those plates, not until I scanned them later, in February. And so you pass your gaze over all these stars to see, you have to be conscious of seeing every star image because you don't know which one's going to shift, if any of them shift. And so it's a very tedious work, and you go through thousands, tens of thousands of star images you see. Well, came to one place where it actually was, turned the next field, there it was. Instantly, I knew I had a planet beyond the orbit of Neptune because I knew the amount of shift was what fitted the situation. And that was the most instantaneous thrill you could imagine. It just electrified me. Well, it was an intense thrill. It made my day. That was the 18th of February, 1930, about 4 o'clock in the afternoon. Well, I realized in a few seconds flashed that I realized I'd made a great discovery, that I'd become famous, and I didn't know what would happen after that. So it was a very, very intense thrill. You don't have that kind of a thrill very often. Well, at first I had a little sense of caution. I thought, I better check this at third plate, which is on another date, see if there's an image there in the right place that would be consistent with the images on the other plates. That was the final proof. Sure enough, it was there. So then I knew for sure, I was 100% sure. Well, I told the assistant director across the hall from me, this machine makes a clicking noise, and you could be heard in that part of the building. And his office across the hall, and he said, of course, he understood blinking business too. He'd been involved in some of the earlier searches. And he said, I heard the clicking suddenly stop in a long silence, and he surmised I had run onto something, you see. And so I was checking out the third plate and all that kind of thing. And here this poor man was sitting at his desk in terrible suspense, waiting to be invited in for a look, you see. I didn't know about that until he told me later. Well, I showed him the plates, the dates, and all that. Everything seemed to be consistent with putting the object beyond the orbit of Neptune, and I went down and told the director. He came up and looked and so on. So the Lowell Observatory was changed from that day on. They realized I really had a prize. And, of course, they probably felt a little bit strange, especially VM Cipher, because he had gone through the Pluto field and missed Pluto 1 year earlier. Missed it on the plates. He was doing blinking. He wanted to be the one to find Pluto, and he failed. So I suppose he probably felt a little chagrined, but he realized and knew that I had something, because the aspects were very convincing. And So then they got in touch with the observatory trustee who was living in Massachusetts. He's Lowell's nephew, and told him about it. And so it was kept secret for a few weeks so we could follow it and get learn more about it, so we could publish more about it when it came out, because we knew that when it was announced, it had been an avalanche, you see, and it was. It exceeded what we expected. And so we kept it secret for about 3 weeks. Unfortunately, so many of the Greek gods and goddesses had been given, the names had been given to the asteroids beforehand, so there weren't really very many choices left. Pluto seemed to be a good name, so the staff voted on it unanimously to adopt the name of Pluto. We considered many names, of course, and Pluto was the final selection. It was just chosen by the staff of the Lowell Observatory. And so the Lowell Observatory director proposed this name to the American Astronomical Society and the Royal Astronomical Society of Great Britain, that this name be given to the planet, and both bodies accepted it unanimously, so we know the name would stick. And that we realized in the case of the discovery of Uranus that the name originally did not stick. We did not want to repeat that mistake, you see. And so Pluto has stuck. Pluto was the god of the underworld, or lower world, I guess it'd be better to say, of Hades. Pluto's out there far from the sun, where sunlight is the average distance. Sunlight is only 1/1600th as bright as on Earth, rather dark. And if you think of Hades as a dimly lighted place or outer darkness, it kind of fits in somewhat with the characteristics of Pluto, probably, or the Hades. So it seemed fairly appropriate from that standpoint. And then when the satellite of Pluto was discovered in 1978 by Christie at the Lowell Observatory, he named it Charon. His wife's name was Charlene. Now, Charon was the boatman who ferried the souls of the dead across the river Styx to Pluto's realm of Hades. So the satellite name fits in very well with Pluto, you see. And Charon didn't have to be used. So that was good mythology there. Soon after the discovery, there was some apprehension that maybe this object I found was on an interloper, that the real Planet X was yet to be found. So they said they want me to go on searching more. So I searched over a lot more of the sky, and no Planet X ever showed up. Went on searching more of the sky to look for this Planet X that may be out there still unseen. And then, of course, I got a scholarship at the University of Kansas to go to school, and I went to school there from 1932 to 1936. But I'd come out every summer and scan more of these plates, you see. And then I went back 2 years later and got my master's degree. So all that time I was associated with the Lowell Observatory, you see. And, of course, I took courses in higher mathematics and physics and the sciences and so on at the University of Kansas. And that's where I met my wife, Patricia. I don't remember the titles of them. I had one book that I got called The Pith of Astronomy, a very amateur or popular book, which I read so many times I practically memorized it, you know. And then other books, I don't recall the names of them. Of course, a lot of them are now obsolete, but it was the best I had at the time. I got them from the Streeter Library, Streeter, Illinois, where that was a hometown. And I went to high school there 2 years. I was 22 years old when I made the third telescope, the 9-inch, which was a very successful instrument. I was 22 years old. And you need to have a place where the temperature is constant, like an underground cave in a cave, so you don't have thermal problems with the glass, you see, when you're working with it. And so in fact, we had to build this cave ourselves a few years earlier. The farmers like to have a place like that for keeping cream and butter and eggs and stuff, you know, cool in summer and warm in winter. Also as a storm protection, because sometimes we had some bad storms and you didn't know whether a tornado would come along and blow your house away. The best thing was get down in that concrete cave, reinforced concrete, you see. So it had a very special purpose. It was a marvelous optical workshop for me. So that's when, of course, I would grind these mirrors. I have 2 discs of glass. One would be on a stand or a barrel, and you rub that over with strokes and rotation and so on, so you grind the curve into it, you see. and then you go through the finer grades, and then finally you polish it on a shaped lap of melted pitch, which gets solid, and you use rouge and water to polish it. And then you polish the exact curve at the very last. It's very, very fine work, you see. And then you have tests for watching, seeing these errors. It's unbelievably simple. All you need is a tin can with a tiny little pinhole in it, about 1/100 of an inch in diameter, which serves as an artificial star, and that goes out and strikes the mirror and returns and makes an image of the pinhole. You put this to the little one side, and the image will be here. And then you just have a safety razor blade on a block of wood. By cutting different places, you have highlights and shadows, differences, which tells you where the errors are, which is high and which is low. It's that simple. And yet you can see the errors down to within a few minutes of an inch by that because you have the long optical leverage you see. It's that simple, but it's tricky. When I sent my mirror to Wichita, Kansas, to a French telescope maker to silver my mirror, because I didn't have the facilities to silver the mirror, he liked he apparently tested my 9-inch mirror and thought it was a very high quality. So he offered me sort of a lukewarm invitation to come and help him make telescopes. That was east to Wichita. Now, I could have gone that way. In the meantime, of course, I was wondering what I'd do if I didn't do that. I said I love steam engines, and so I really had a kind of a secret ambition. I'd like to become a apprentice fireman and a railroad engineer, because I just loved machinery and travel, you see. And I had a profound love of trains, you see. And, of course, when the offer from Flagstaff came, that changed all that, suddenly an entirely different direction. Well, when I was on the farm, we got hailed out, and, of course, that meant a total lack of money. I couldn't afford to go to college, and this was a blow. And so I realized that I would have some very tough sledding, and I was pretty discouraged because I didn't see much hope of getting into the field I wanted to get into, with no college education and so on. Didn't know anybody particularly important in the field, so I rather felt I was under a great disadvantage and really could hardly hope to do what I did finally become. And so the break came to go into Flagstaff, which did the trick. It's depressing, very depressing. I worried about how I would make a living. I did not want to stay on the farm. It didn't offer the kind of challenge that I wanted. And yet, without a college education, I felt that I was really out of luck. I just kept on studying, and then the breaks came. I kept making telescopes and learning more about optics, and of course, that's the knowledge that paid off. I was really preparing myself for the better thing that I didn't realize at the time. And so, of course, getting an invitation to go to Flagstaff was a piece of real luck. But the other was preparing yourself. I like to think of as I think now, of the Chinese philosopher Confucius. He said, "The future belongs to those who prepare for it." And I never forgot that. I never thought of it that way. As I think the driving thing was curiosity about the universe. That fascinated me. I didn't think anything about being famous or anything like that. I just was interested in the concepts involved, and to soar out through the unlimited amount of imaginations and experiences. That's what interested me. Being invited to come to Flagstaff was a big stroke of luck. The other was pluck. Really, not really realizing I had been preparing myself for that for years before that, you see. Look at the telescope, learn to find objects in the sky, reading everything in astronomy I could get, you see. So, and to be very careful, I was somewhat of a perfectionist, you see. And those were the traits that made it as a good candidate for this type of a job, you see. I had a strong sense of responsibility. I wanted to be flexible also. And I just worshiped knowledge and spared no pains to do the job very well. And I think that's an enormous amount of perseverance. I learned that on the farm, you see. And I guess those are the qualities that got me there. Well, you carry on through even in spite of discouraging situations, and you never lose sight of the goal. And often you experience hardships involved, like freezing in a cold dome at night and so on, loss of sleep. That gets pretty wicked. but I was interested in getting the results, you see. So it takes a dedication to achieve that kind of thing. A lot of people would give up and quit, you see. I did love engines and machinery. And to me, the noise of a thrash machine is better music than a lot of music I hear nowadays. Because I took a man's place in the thrashing crew when I was 13, 14 years old. That was during World War I, and there was a shortage of manpower, and so every boy in the early teens had to take a man's place on the farm and the field work and harvest and thrashing. And so that's where I learned to work hard. And I shed many a tear when the steam engines went out of style on the railroads. I shed many a tear over that. Well, I'd never been to college. And I got offered a scholarship at the University of Kansas. I couldn't take it up the first year because the search was in a critical phase. So in the fall of 1932, I went to Lawrence, Kansas, and entered the university as a freshman and took all the courses except they wouldn't let me take beginning astronomy. And I thought that was going to be a nice snap course. They wouldn't let me take it. I felt a little bit cheated on. There were a lot of byproduct materials I wanted to work up after I got done the scanning. I learned a lot about the distribution of galaxies in the sky. I counted over 29,000 galaxies on my plates, and I found that what I saw did not agree with Hubble's view of the galaxies at all. In fact, I had arguments with him about that. It turned out I was right, as everybody knows now. Well, if I had stayed, I would have worked all this out a decade earlier than when it was finally worked out, as byproducts of the planet search. I discovered new star clusters, clusters of galaxies, and one great supercluster of galaxies as byproducts. Hundreds of new variable stars and all that, hundreds of new asteroids, 2 comets. All that I left behind because of the change in the regime. So World War II had a drastic effect on it drastically changed my life. I kind of felt like I'd somewhat in a way failed, maybe, but it wasn't my fault. When I went back after teaching navigation in the Navy, well, those years I thought, well, I'd have a job, and there was no job there again. That kind of left you empty-handed. And that was kind of a blow. But it worked out for the best anyway. The best thing ever happened was leave there. My first experience of teaching was during World War II. I was in the military draft, and I was assigned to teach navigation in Navy school, teaching navigation for 7 semesters. And I put hundreds of young men through a tough navigation course. It was very overloaded, really, because we didn't have enough teachers. Astronomers were good candidates for teaching navigation because they understood the basics of navigation theory, you see. And so a lot of astronomers were pressed into teaching navigation because of the terrible shortage of teachers. And we were suddenly faced with the necessity of training a lot of young men the art of navigation. So that's how these things got set up over the country, you see. And they had one at Flagstaff at the Arizona State College at that time. During the war, I was teaching navigation in a Navy school. And when I wanted to go back to the Lowell Observatory to resume astronomical work, the observatory was short of funds, and so they let me go, and that kind of hurt my feelings. But in the meantime, I was invited to come to White Sands Missile Range to supervise the optical instrumentation. Some of the people thought with my experience with telescopes and all that I could do that kind of work, and it turned out I was just the man for the job. And so I came to White Sands in August of 1946 and saw almost all the German V-2 rockets fired, along with our American rockets. So I had about 80 men under my supervision. About half of them were military people, and others were civil service. My rank in civil service was equivalent to a lieutenant colonel. And I had a big responsibility of getting the ballistic data on these rockets, you see. So it was up to me to decide where to put my instruments for the strategic positions. To measure these high-speed rockets was a real challenge, but we did it. And again, it was in mathematics. I used a lot of trigonometry out there, knowledge of optics and so on, and designed super cameras and got marvelous results, which really put the White Sands Missile Range on the map. So I had a lot to do with modern instrumentation of rockets. Well, at first I wasn't sure I'd like it, but of course the optical problems rather fascinated me. And so here's where I could make a real contribution to the service of my country. You see, at that time, after the war, the Russians turned suddenly unfriendly, and that bothered me. And I thought, well, they're testing a new brand of rockets, missiles, namely rockets, you see. We need somebody who knows how to get instrumental data on them in flight. And so I thought this is where I could make a contribution. And I'm glad I did. We had some dangerously close calls, but it was very challenging. It was very exciting. I saw a lot of them explode on the launcher in the air and so on. Very spectacular 4th of July fireworks, I can tell you. These were powerful missiles. And I tracked a lot of them myself with theodolites and tracking telescopes. And so I got thoroughly acquainted with the Army, which I never knew much about before. I worked with every rank in the Army, from the commanding general to the buck private. And I had several military people under my supervision even. And so I designed new instruments for particular jobs of the work, which proved to be very successful. In fact, this one instrument we called the IGOR, I-G-O-R, meaning intercept ground optical recording, as a super camera. They worked so well that they were used on White Sands for the next 30 years before they retired them. And then they got some a little bit bigger, the same kind. I designed optics for replacement with some of the German optics on the instruments they had to make them more powerful, and they worked very well on the White Sands Missile Range. You see, some of these things we had to be quite some distance away because they were too dangerous to be close. Some of the rockets would accelerate so fast you had to be back at least 10 miles from the launcher to be able to handle the tracking rate. It was very fast. It was a real challenge. You knew you had a tiger by the tail when you're trying to track some of these solid propellant missiles. They'd pick up full speed in about 4 seconds. And all this came about from what I learned personally working on mirrors in the cave in Kansas. No one seemed to have the perspective of how they could apply this to this new field. And as a matter of fact, I had to write the job descriptions of all the different kinds of jobs in my section because there was no precedent at all in the civil service. They didn't know how to set up the job descriptions. I had to write those too. Well, it took quite a little adjustment because I didn't expect to live that kind of life. I've been making adjustments to it ever since. People want autographs by the thousands. They want to talk to me. They want me to give lectures. And by the way, I did give a series of lectures of 4 years traveling over the United States and Canada, raise money for a Tombaugh scholarship for postdocs in astronomy here at New Mexico State University. And we raised, counting the matching money, would be close to $500,000. Well, I get pressed by the public all the time. A dozen of people after me all the time for favors. You just get them. It really takes up a lot of time. And I just don't have time to do the things I really want to do. I can ignore some of it I can't. And I have a new school out a mile south of here, a big new grade school called the Clyde Tombaugh Elementary School, which the people of Las Cruces named in my honor. And every young kid in that school knows I found Pluto. And it thrills them to death that they go to the Tombaugh school, see. So I'm doing all right in this community. They've given me great honor. Letters pour in by dozens and dozens. I go to conventions, meetings every year to some meeting. So I'm in constant contact. And it's fun to chat with people, you know. For example, a year ago last June, we had a meeting of the American Astronomical Society in Albuquerque, and the people who were the high moguls on the NASA space service, the Voyager mission people, I had lunch. They invited me to have lunch with them. That was a high for me. Those men are marvelous talent. I just think of myself more or less as a guy. I look to others, I look up to them as that they are the achievers, you see. Of course, I realize I'm an achiever too, but I don't think of it so much that way. To me, what I achieved was the most logical. I don't think it's particularly difficult, but other people say that was very difficult, you see. It came kind of easy for me because I understood it for some reason, natural understanding. And that was happened to be my Latin talent. I think it's part of being a scientist. You have to have an alertness to deal with when you encounter the unexpected. There have been a lot of history of science is filled with almost made discoveries missed by a hairline because they didn't have the alertness to realize they had a discovery. One sees a lot of tragic examples of that in science. Now, to take the case of the French astronomer Lalande in 1795, he was making a star catalog, and he was a very careful observer. He would sketch the position of stars in the field, you see. He'd go back a few nights later and recheck them to make sure he hadn't made a mistake. Well, he happened to have Neptune in one field on the 8th of May, 1795. And so 2 nights later, he went back, and that one is in the same place at a different position. He thought he had made an error in the position. He was actually witnessing the movement of planet Neptune and didn't have the alertness to realize he found a planet. He couldn't have had a better clue. Where was his imagination? I find a lot of scientists do not have much imagination, and they do not make big discoveries because they miss them. There are some people who are just plotters and work right along routine stuff. They seem to like it, and that's all they're capable of doing, but they do it well. The others who have imagination to see the unknown and interpret the unexpected. So you have these various different kinds of scientists, you see. I was generally always looking ahead and so on. And I used to do all kinds of things for entertainment. Back in the days when I was young, we had no radio, no TV. We were 30 miles from a public library out in the sticks in western Kansas. And so I do arithmetic exercises. For example, I'd calculate how many kernels of wheat were in 10,000 bushel granule just for the heck of it, to see how big the number was. And even calculate how many cubic inches there were in the supergiant star Betelgeuse. It's 1 followed by 39 ciphers. I could still read the number. Well, this way I learned to get a grasp of the meaning of numbers, you see. And so the thing I regret to see nowadays in the media, where they mean billions instead of millions and vice versa. They don't seem to understand the difference between a million and a billion. It's a terrific difference, a thousandfold difference. And yet they don't seem to have the intuition to realize that that's the wrong answer. They say million and they mean billion or vice versa. Now and also the thing that really pains me is the ignorance of geography among people today. It is astounding. When you have a lot of people who cannot identify the United States on a world map, that's pretty bad. There's no excuse for that kind of ignorance. And when people travel a lot, why don't they learn some geography? It's interesting. Then you know where you're going. See, I value knowledge very highly. And it never hurts you. And in fact, it gets you good jobs if you have knowledge. And yet a lot of people aren't willing to take that attitude or willing to take the trouble to learn. It does require effort to learn. And if you're too lazy to think, well, then you're out of luck. Well, I like to raise a question. Have you ever thought about what lies in the sky above you, that the Earth is not the only place in the universe? There's a great universe out there, vast. You ever think about that? We're only a small part of it. We ought to think about that, to learn our place in the universe, you see. And so I like to try to raise the curiosity of what is out there in space, you see. A lot of unsolved mysteries, challenging. You're filled with wonderment, baffled at the some of the puzzles that you can't solve. It's a never-ending challenge. I have this feeling of a wanderlust. I like to kind of look there and just sweep around through the Milky Way and say, oh, there's hundreds and hundreds of stars and star clusters. It gives me a feeling of great elation. It's a therapy for me. Just idle, plowing through the sky, you know. It's fun. And wonder what all the wonderful things that must be going on there that we don't see. Realizing there are thousands and thousands, millions of alien civilizations out there doing things, so maybe something like we are. This is something you think about. Our sun is going to be so peculiar as to be the only one out of octillions of stars, be the only one having a planet with life on it. That's totally against the odds. Even if you have only one star out of 10,000 that has a planet that is right for life, the number of stars in the sky we know now from sampling with the big telescopes, there are a number of stars as 10 to the 21st power. Now, that doesn't mean anything till I tell you that the number of grains of sand on all the Earth's ocean beaches is only 10 to the 19th power. So there are 100 stars for every grain of sand on all the Earth's ocean beaches. Now they're not all sterile then. How could they be? We have to realize there's this enormous potentiality of trillions of planets out there with alien civilizations on them. We are not the center of the universe. We're not all that important. And we're not alone. So that's my perspective. You see these things in the sky on your plates, and it's a wonderful education. And you're made aware of the enormous vastness of the universe and all the things that may be in it. That, to me, is a very challenging thought. I'll have to dwell on that wonderment. Well, unfortunately, a lot of the concepts in the Bible are obsolete. They're based on ancient and obsolete mythology. And that doesn't fit the findings of science. So I had to choose one or the other. And so I regard it as a history, in a way, valuable for teaching morals and all that, but as a teaching science, it was no good. It was misleading. That was the attitude I took. I had a drastic revision of my religion. You see, during the Scopes trial in 1925, Tennessee, I was 19 then, and I became thoroughly disillusioned with the what I consider ignorant fundamentalist points of view. I got thoroughly disgusted. And our minister would rank and rave against science every Sunday all summer long. I got thoroughly disgusted with that kind of stupidity. So I have never got over that. So I am not a Christian at all. I just cannot reconcile myself to that point of view. I used to be, but I abandoned it. I think there's a supreme power back of the whole thing. Intelligence, when you look at all the instincts of nature, both animals and plants, very ingenious ways of that survive. If you cut yourself, you don't have to think about it. Your hand, something there heals it, stops the bleeding, puts a scab on. There's something marvelous, a miracle there. How does a pansy, for example, select the ingredients in the soil to give the right colors for the flower? Now, there is a great miracle, you see. So I think there's a supreme power behind all of this, as I see it in nature. Of course, heaven is no place in the space out there. I don't know where it would be. There's one place I think they could say where hell is. That's on the planet Venus, because the temperature is 900 degrees and no water, and it rains sulfuric acid, and the atmosphere is 90 times more oppressive than here. So that's a good place for hell. Just the next planet over. They have set up some facilities where they're trying to listen for possible intelligent signs of somebody radioing to us that shows intelligence somewhere else in the universe. And so far they haven't found it yet, but who knows what they may find. The only trouble is a lot of them are too far away. Don't have the signal strength to get here to be picked up. But they're listening. Well, of course, I remember some of the science fiction, which, of course, have come true. One of the things that really fascinates me is the speed of light and electromagnetic radiation. For example, we can radio to astronauts on the moon. It gets there in 1.25 seconds. How could it get there that fast? Now, that's something to marvel about. Can you visualize a mechanism that would permit that kind of a speed? I'm just simply flabbergasted. I cannot imagine a mechanism that is able to accomplish that kind of a miracle. Yet we know, we talk of the astronauts on the moon just like the next door, Isn't that a marvel? That's a tremendous accomplishment in communications. To talk to people in another world. So I don't see how people can nowadays, with all these marvels they're finding, how could they can possibly be bored with life? I just don't understand that. To me, it's all exciting. How can they be bored? That's just beyond my understanding. One of the things that fascinates me is the question, is the universe finite or infinite? Either one is impossible to imagine. So how do you handle it? Well, I finally kind of gave up and settled for a compromise, and so I say I guess the universe is semi-infinite. It's the best I can do with it. We don't know. We have never found the edge of the universe yet. As far as we've gone out to about 11 billion light years and haven't found the edge yet. There are millions of galaxies like our own Milky Way. Our Milky Way is one galaxy, which contains about 200 billion suns in our own galaxy. And all these millions are like it, like our own galaxy. With hundreds of billions of suns out there, each one of them. Now, all those stars can't all be sterile with no planets of life on them, can they? It just doesn't make any sense. So you wonder, what is the purpose of the universe, if there is a purpose? We don't know. I'm afraid that we sometimes are a little bit vain, that we think the universe is made for us. I'm not sure of that. That's our own vanity showing up. Well, that's sort of my religion. Ponder on these things. And, of course, a lot of answers I don't know, never will know. But that's fun to think about them.